In the next few MIA prep lessons, we're going to take a look at significant figures. What's a significant figure? Well, a significant figure is just a number we know the value of. And we've never come across this in math class because in math class, our teachers just give us the numbers. And so that's what it is. We know it exactly. But in the sciences, we go out in the world and we measure numbers. And we can measure them more precisely or less precisely. And we want a good way to communicate that to each other. We want to let each other know how well we've measured something. And so in this first lesson on significant figures, we're going to learn what makes a figure significant or not significant. And by the end, you'll be able to look at a number and count how many sig figs it has. Let's take a look.
Significant figures are an important concept in chemistry, but they're also a little tricky to nail down. So first what we're going to do is we're going to talk about what is a significant figure and why do we even need them? And then we're going to talk about the rules that scientists use to count significant figures. So first, what's a significant figure? Why do we need them? Well, let's say you go out on the street and you ask somebody, what's the population of the United States? And they say 320 million. Now, let's say we go Google it and we find it's actually 320 million and 1 people. Is their answer wrong? Well, most of us would say no. We understand that these last zeros here, in particular, aren't really zeros they're claiming to know about. They're just using them as placeholders to make the number 320 million. But we know that they don't mean exactly 320 million. They're rounding a bit or estimating. There's a little imprecision in what they're saying. And that's normal and totally fine in everyday communication. But for a scientist, it's a problem. Because if you want to communicate very clearly which numbers you know and which you don't, we need some set of rules when we report numbers. So for example, if you're the US Census Bureau and you find out the population of the United States is actually exactly 320 million, how do you communicate that in your report so people know you're not rounding at all? That's where sig figs come in. Significant figures tell us about how well we know a number. And so the rules we're going to go through next are going to tell us how to count significant figures. Which number do we know about? Which number do we not? So the very first rule, and probably the simplest rule, says that non-zero numbers are significant figures, which I'll commonly abbreviate as sig figs or maybe even just SF. So rule 1 just says non-zero numbers are sig figs. So if we go to this number 3,743, we see that all those numbers are not zeros. So we have 1, 2, 3, 4 numbers. And so what that's communicating is I know all 4 of those numbers. So if we've counted our sig figs there, we'll see we have 4 sig figs, which I'll abbreviate SF. So that's rule 1. That covers all non-zero numbers. So as you can imagine, the next few rules cover zeros. And we're going to categorize zeros in a couple different ways and talk about which ones are significant and which ones aren't. So the first type of zero we're going to talk about is a leading zero. It comes at the beginning of the number. And it turns out leading zeros are not sig figs. Rule 2 just says leading zeros are not sig figs. And what are leading zeros? They're just all the numbers that come before the non-zero numbers. They're at the start of your number is another way of saying that. And so when we go up to this number with all these zeros in the 4-2, we see that all of these zeros come up front. So they're leading zeros. So I'm going to put an L up there for leading. And we know from rule 2 that they're not sig figs. So if we go to count sig figs, we don't count any of those. They don't count because they're leading and they're not significant. On the other hand, 4 and 2 both count because they're non-zero numbers. So by rule 1, we know those are sig figs. So how many sig figs does this have? Just 2. So this number has 2 sig figs. And to get that, we had to apply rule 1 to know that 4 and 2 were significant, and rule 2 to know that all those zeros weren't. Okay, the next category of zeros we're going to talk about is sandwich zeros. So sandwich zeros are just zeros that come between significant figures. They're in the middle of your number is another way to think about that. So rule 3 says zeros between sig figs are sig figs themselves. So sandwich zeros are just zeros that come between 2 sig figs. So if we go look at this number above, we'll actually see that there's 2 different types of zeros. The first 3 zeros come at the beginning, and we call those leading zeros. If we go to this next set of zeros, they actually come between the 2 and the 1. So they're what we call sandwiched between the 2 and the 1. So I'm going to write an S above those for sandwich zeros. So we've labeled the different types of zeros we have. Now we know all those leading zeros aren't sig figs by rule 2. The 4 and the 2, however, are sig figs by rule 1, which says all non-zeros are significant figures. The new rule we're introducing, rule 3, tells us these two sandwich zeros, both sig figs, because they're sandwiched between non-zeros. This last number, 1, also a significant figure. So how many sig figs do we have there? 5. All right, rule 4 tells us about the last category of zeros. So we've talked about leading zeros. They come before the number. We've talked about sandwich zeros. They come in the middle of the number. And now we're going to talk about trailing zeros. They come at the end of the number. So trailing zeros are a little trickier than the other two categories. And that means that when you're thinking about these significant figure rules, it takes some practice working with them to get them down. So if you still feel a little unsure of how to apply them, that's normal. It takes some practice to get used to applying these. Okay, so rule 4 says trailing zeros are not sig figs, unless there's a written decimal place. So if there's a written decimal point in our number, that actually makes the trailing zeros sig figs. So I've written 300 twice in the top part of this slide, and they actually both have trailing zeros. So here we see these last two threes come at, or last two zeros rather, come at the end of the number. So I'll put a T above them, they're trailing zeros. Similarly, on this bottom 300, all three of these zeros come at the end, they're trailing zeros. So if we go to the top 300 and we want to count sig figs, the first one's a significant figure by rule 1, which says all non-zeros are sig figs. Those next two zeros, though, are trailing zeros, and there's no written decimal place. That means those zeros are not significant. So this guy just has one sig fig. On the other hand, if we look at the trailing zeros on this bottom 300, we see that there actually is a written decimal point. Since there's a written decimal point, that makes all of those zeros significant figures. 1, 2, 3, 4 sig figs for that guy. So remember, our last rule says trailing zeros are not significant figures if there's no decimal point. That's like the top 300. However, if there is a decimal point, that makes them all sig figs. So the bottom number then has 4 sig figs. Now, this should actually hopefully make some intuitive sense. If I go weigh myself, and I come back and I tell you I weigh 300 pounds, you know that what I mean is maybe 301, maybe 302, maybe 303. You know I'm rounding. On the other hand, if I come back to you and say I weigh 300.0 pounds, you're going to take from that I weigh exactly 300 pounds. So sometimes we actually have followed these rules in everyday language without even realizing it. Hopefully that gives you a better idea of what sig figs are for. If I tell you I'm 300 pounds to 4 sig figs, that means I'm exactly 300 pounds. If I tell you I'm 300 pounds to 1 sig fig, that means I'm around 300 pounds. Maybe I'm 301, maybe I'm 298 pounds. I'm roughly 300 pounds. So that's why sig figs are useful. All right, last rule. Luckily, this one's a pretty straightforward one. It's about numbers in scientific notation. So whenever you see that times 10 to the whatever, so here in this top number, you see times 10 to the minus 4, you know that you're dealing with a number in scientific notation. And the rule here is for significant figures, every digit's written is a sig fig. So rule 5 just says all digits written in scientific notation are sig figs. So here all we got to do is count up our digits. 1, 2, 3, 4. You might say, why does the 10 and the minus 4 not count? Well, all they're doing is shoveling that decimal around. So when we say all digits written in scientific notation are sig figs, we mean all the digits before that times 10 to the whatever. So here we have 4 sig figs. So those are the rules that we use to determine what a significant figure is. And that is how we can count them. Now you might feel like you need a little more practice with these rules to get them down. If you feel that way, I suggest watching my video, Counting Significant Figures, practice. And that should give you another chance to apply these rules and learn them a little better. The eventual goal should be able to count these sig figs without even looking at the rules. Hey, hey.